NFPA 99, the Healthcare Facilities Code, Chapter 7 concerning electrical systems, Section 7.2.1.10 addresses emergency lighting. Emergency lighting circuits shall be identified and maintained in accordance with the Electrical Inspection Authority's requirements. In buildings where an emergency generator is provided, emergency circuits shall be supervised by a transfer switch. Section 7.2.1.10 states that emergency lighting systems shall be capable of operating upon loss of normal power for a minimum of 1.5 hours. An exception is permitted to reduce this time to 30 minutes upon loss of normal power if an acceptable smoke purge system is provided that maintains a tenable atmosphere for evacuation of occupants. Section 7.2.1.10 requires that emergency lighting systems shall be designed to operate from the emergency generator set, including service entrance or entrances, feeders, and branch circuits required to energize the lighting loads for the required duration. The National Electrical Code, NEC, Article 700 pertains to emergency systems. Section 700.9 states that emergency lighting systems shall be designed and installed in accordance with NFPA 99. Considering a scenario involving 1000-watt metal halide high-intensity discharge lighting with a 250-watt quartz strike as part of the emergency egress lighting system, the question arises regarding the suitability of modular wiring systems, often abbreviated MWS, for emergency lighting powered by a generator. It is important to carefully evaluate whether such wiring systems are code compliant and appropriate for this application. Modular wiring systems offer benefits such as ease of installation and flexibility, making them attractive for general lighting installations. However, their use in emergency lighting circuits requires thorough consideration of safety, reliability, and code compliance. When evaluating the acceptability of MWS for emergency lighting, several factors should be considered. Firstly, the National Electrical Code, specifically Article 700, addresses emergency systems. While the NEC does not explicitly ban MWS for emergency lighting, it mandates that emergency systems must meet stringent requirements for reliability and performance. Secondly, NFPA 99, the Healthcare Facilities Code, provides specific guidance for electrical systems in healthcare facilities. Section 7.2.1.10 requires emergency lighting systems to operate from the emergency generator set, including service entrances, feeders, and branch circuits for the required duration. This necessitates a robust and reliable wiring system capable of sustaining operation during power outages. Thirdly, fire resistance is a crucial consideration for emergency lighting circuits. In the event of a fire, it is essential that emergency lighting continues to function to facilitate safe evacuation. Standard MWS may not possess the necessary fire resistance to maintain circuit integrity during a fire. It's important to verify that the specific MWS proposed for the emergency lighting system is listed and labeled for fire resistance, meeting the applicable standards. Fourthly, mechanical protection is vital to ensure the integrity of emergency lighting circuits. MWS should be adequately protected from physical damage, impact, and other potential hazards that could compromise their functionality. This protection may involve installing the wiring within conduit or using other suitable methods to shield it from damage. Fifthly, secure connections are paramount for emergency lighting circuits. MWS connections must be reliable and secure to prevent accidental disconnections that could render the emergency lighting system inoperable. Connections should be properly torqued and secured to prevent loosening or separation over time. Sixth, the Electrical Inspection Authority having jurisdiction must approve the emergency lighting system, including the use of MWS. The authority will assess the proposed installation to ensure compliance with applicable codes, standards, and regulations. It is important to consult with the authority early in the design process to address any concerns and obtain approval before proceeding with the installation. Seventh, consider the type of occupancy. High-rise buildings may have more stringent rules due to the height and evacuation times involved. If the building has a fire command center, the MWS wiring should be routed in a way that it is not compromised by a fire to maintain the integrity of the system. 8th, regular inspections and maintenance are essential to ensure the continued reliability of the emergency lighting system. Periodic testing should be conducted to verify that the system functions as intended during power outages. Any deficiencies or issues identified during inspection should be promptly addressed to maintain the system's operational readiness. 9th, use-listed components, meaning they were tested and certified by a third party to meet specific standards and safety requirements. Make sure the connectors and wiring are rated for the intended use, including the voltage and amperage of the emergency lighting system. 10th, consider using redundant wiring for critical emergency lighting circuits. This means having two separate wiring pathways for the same circuit. If one pathway fails, the other pathway will ensure that the emergency lights continue to function. Redundant wiring provides an extra layer of protection against potential failures. In conclusion, while MWS systems may be acceptable for normal lighting, they are not typically designed or rated for use in emergency lighting systems. Therefore, it is not recommended to use MWS for emergency lights that are required to operate off of emergency power or a generator. If you decide to use MWS for emergency lighting, ensure that the selected system is specifically listed and labeled for such applications and that it meets all applicable code requirements. Consult with the authority having jurisdiction and engage a qualified electrical engineer to ensure that the installation is safe, reliable, and code compliant.